Good morning, good afternoon, good evening, wherever you are joining us from. My name is Laura. I'm with Treasure Data. I run all of our events and field marketing. We're very happy that you have joined us. We are very excited to talk about managing slowly changing dimensions using Treasure Data Workflow today. This is our fourth hands-on webinar. We're excited to bring you more in the future. More information about that will come later. So just before we get started, there is a handout for you. It's the full slide deck of this presentation. If you'd like to download that, you'll find that in your GoToWebinar console. Also in the console, you'll see a section where you're able to ask us any questions that you have. Go ahead and anytime during the presentation, any questions that come to mind, just type them down, send them on in. We will get to as many questions as we can at the end. So without further ado, I would like to introduce Scott Mitchell, who is a Senior Solution Engineer here at Treasure Data. He has 7 years experience as a data professional with a background in startups in e-commerce, fintech, and paid media. He's a big fan of audiobooks and green tea. So welcome, Scott. It's morning for us. I'll say good morning. Thank you for joining us.
Awesome. Thanks, Laura. Welcome all to this workshop on handling slowly changing dimensions with a Treasure Data Workflow. Just a quick overview of what we'll cover today. We'll start with an introduction to Treasure Data and Treasure Data Workflow. Then we'll give a quick overview of what slowly changing dimensions actually are. We'll take a look at how window functions work, because we'll need those. And then we'll put it all together in a hands-on application, implementing all the above to handle slowly changing dimensions using Treasure Data. Just by way of introduction, my name is Scott Mitchell. I'm a Senior Solution Engineer here at Treasure Data. I help our customers gather, unify, and get the most out of their data. And my contact information is here just in case you want to talk in more detail about anything that we cover today. We're going to get into the weeds today on a very specific application of the Treasure Data platform. So I want to take a brief moment at the beginning here to give a high-level overview of the product before we zoom in on a very specific use case. So Treasure Data is a customer data platform, or a CDP. And as a CDP, what we enable our customers to do is to automate and streamline the ingestion of data from multiple disparate sources of data. From there, they can clean, unify that data to create a single 360-degree view of their customer. They can then divide those customers into segments and audiences, take action on that data through integration through any of our connections with external marketing systems. So this slide, visualizes. Oops. Change the slide there. There we go. This slide visualizes how that process really works. First we're able to unify your first-party data and enrich that with second and third-party data. Then use our powerful data management functionality to organize your data into customer profiles, which like I mentioned, can then be segmented based on their attributes and behaviors. And then finally, Treasure Data allows you to take action on the data you've collected. That can be personalizing marketing campaigns, targeted advertising, social media, reporting, BI, data science. So I'm going to spend most of this webinar talking about this section here with the cloud over it. And this is where all of the data pipeline management functionality lives. And which, what this lets us do is build repeatable data processing pipelines specific to the job that we want to do. Next slide here. So, as I mentioned, all this functionality lives in Treasure Data Workflow, which I'll give a quick overview of now. Treasure Data Workflow is a data orchestration and workflow management tool that allows us to write code in YAML syntax and to orchestrate the execution of jobs on Treasure Data, be it data input, data processing, or data activation. And the core engine of Treasure Data Workflow is actually built on the popular open source project DigDag, which was actually invented by Treasure Data engineers. As I alluded to before, ultimately what Treasure Data allows us to do is build repeatable data processing pipelines that consist of Treasure Data jobs. And a really powerful dimension of this is that these workflow scripts are just YAML files, they're just code, so they can be treated like the rest of the code in your project. And they can be checked into version control, used in unit testing, or just like any other script. So what this means is a high level of organization and visibility into your data processing, which can mean easier collaboration across teams, pipelines that are easier to fix and troubleshoot and maintain, and functionality that allows you to handle errors easily and then well.
I'm just going to jump in here. If you're curious about workflow, one of our previous hands-on webinars was all about Treasure Data workflow. So in the follow-up email to this, I'll include the link to that so everybody can watch that webinar and get more of a deep dive there.
Awesome. Cool. Thanks, Laura. So this is what a sample workflow script might actually look like. As I mentioned before, this is YAML syntax, and the different operators are grouped into tasks that start with a plus sign. And so what's happening in this script here is a time zone and a schedule is set, a database variable name is set, and then there are 3 tasks that start with a plus sign: a load, daily, and monthly. So the first task, the load task, looks to be loading from an S3 bucket to a table called monthly goods sales. And then the second one runs a query and creates a table with the results from that query. And then the last task executes another query and takes the results from that query and writes them back out to an S3 bucket. There's actually a huge library of operators you can use when writing workflows. This is a list of just a few of them. I urge you to check out the documentation to see what all of the operators are. You can do things like store the results of your last query to reference in your next query. You can execute for each loops and conditionals. You can state whether tasks should run synchronously or in parallel. Import export from any Treasure Data connector. You can echo out custom logs. There's lots of functionality here to build out a robust data pipeline. So that's a quick overview of Treasure Data workflow. As Laura mentioned, if you want to dive deeper into Treasure Data workflow, we actually have an entire separate webinar on it that we can link you to. So for now, let's keep that functionality in mind, and we'll switch gears a little bit into talking about slowly changing dimensions themselves. So slowly changing dimensions is really just a fancy term for when a dimension column in a data set is prone to change unpredictably. You could think of a CRM data set that keeps track of customers where occasionally but rarely a customer will change their phone number or change their email or address. And data that you pull in from a CRM usually just presents the value for that dimension as it is now. And it may not tell you that this dimension used to have a different value or give you the history of those changes. And often this current only view doesn't really give marketers enough visibility into their data. They may want to keep a record of every change to their sales data so they can visualize their sales pipeline or analyze that data to make their marketing more efficient. Another use case might be a web log context for keeping visibility into a user's browsing history as cookie data changes. Without a proper log of all the changes to a customer's data, analyses around multi-touch attribution, lifetime value, or churn analysis could become break down or become less accurate. And so analysts who want a record of the history of these changes will need to manage slowly changing dimensions. Luckily, this is a common problem with a prescribed solution, and the best practices for dealing with SCDs fall into one of 4 very unimaginatively named types: type 1, type 2, type 3, and type 4. And I'll give you a quick overview of each of those now. So type 1 actually doesn't keep a history of changes at all. It just overwrites the field. So, say we're given a data set that contains a company ID, company name, and the state the company is located in. So here we have an existing record that shows Sterling Cooper in New York, and then we receive a new record that shows Sterling Cooper has moved to California. If we're using an SCD type 1, what we're left with at the end is a record showing us that Sterling Cooper is in California. That's type 1. So type 2 actually keeps both records and adds a new column that serves to flag the row with the most up-to-date data. So you can see in our final SCD type 2 table, it has both New York and California, but there's a is current column with a 1 next to California, because that's signaling that this California entry is the latest information we have for Sterling Cooper. That's type 2. Type 3 keeps a record of the changes to a column, but is limited because it only keeps the current record and the most recent change. So in this final SCD type 3 record, we have the company state that is current, California, and the previous company state, which is New York. The obvious limitation here is that if Sterling Cooper were to move again, say to Washington, Washington would become current, California would become previous, and the record of Sterling Cooper being in New York would be lost. So that's the limitation with type 3. Side note: there's also a variation of type 3 that will keep current and original instead of current and previous. And lastly, type 4 uses 2 tables with a current value in the main table and then a separate table for keeping a record of the history. So that's a quick overview of the common ways to handle SCDs. Next, I want to actually talk about how to accomplish this with code. And to do this, we'll need window functions. So I'm going to focus specifically on implementing a solution for type 2 SCDs, because it's probably the most complex. So you'll remember that for type 2, we're keeping both rows and adding an is current column to keep track of the row that contains the most up-to-date information. So actually, one key ingredient that we've left out is implementing this using last modified date. Without that, it's pretty hard to keep track of which record contains the newest information. So as we implement this with code, our goal will be to keep both rows and flag the current row with a 1. And so that's where window functions come in. Essentially, they perform calculations across the rows of a query result with partitions where we designate. As far as how they run, from the interpreter, they run after the have-in clause in a SQL query, but before the order by clause. And they appear in the select statement because they return a result that gets displayed in its own column. So there's 3 parts to a window function. There's the function itself. We're going to use rank, but in Presto, there's all kinds of functions available, and I encourage you to check out the documentation to learn what all of those actually are. Rank will essentially return a rank order across the partition that we set. And then the second part of a window function is the partition specification. So what this is where we define the unit across which the function will run. So we're going to use company ID because we want to rank over companies. We want to know the order in which we received each new value for company state. And lastly, there's ordering specification. That's where we give the function a field on which to order the records before ranking them. So when you run this window function, what you get is a rank ordering of each record by descending last modified date, where rank ordering starts over again at 1 for each company. Here, and we only have one company, so what we get is a 1 and a 2 in the is current column. And if we added another company, say CGC, the numbering would start over for CGC because it has a different company ID. And if we changed the ordering specification, obviously the ordering, no surprise, is reversed there. But we don't actually want ones and twos in our is current column. And we want a 1 attached to the most recent record for a company and a 0 attached to everything else. So we can actually do this without much trouble by adding a case when statement. And that should put a 1 in the most current record for each company and a 0 in everything else. And so now what we've done here is written a query that takes raw data and turns it into a cleaned table according to SCD type 2. Let's see here. No worries. All right. But we're not actually there yet. Really this is just a query, and it's not really a repeatable data pipeline that I was bragging about earlier. So what would it take to actually make this an actual repeatable data pipeline? I would see it as 3 steps. First we would want to have a process to load the incremental data from a Treasure Data connector to a staging table. Then we want to drop the final table, or the target table as we're calling it, because it contains outdated SCD information. And then third, we'd want to use a window function on the staging table to rebuild the target table. And written out as a workflow, these tasks look like this, 1 step for each task here. And this is what the end-to-end workflow would look like, written out in the Treasure Data console. And you can see I've set a time zone, a schedule, a database variable, and then set up these 3 steps. What I'd like to do next is kind of walk through this workflow as if I were the interpreter. Before anything runs, assume we have a staging table with a state for Sterling Cooper and CGC, and that both are labeled as current in the target table because that's the only record that we have for that company. The first task runs to load 2 new records, one for Sterling Cooper and one for CGC. And then the second task runs dropping the target table because it's now outdated since we've received new information. And then finally, we rebuild the target table using the staging table and the window function that we just discussed. And after that, the process is complete. The target table now shows a history of the changes in accordance with SCD type 2. And of course, there are probably many different ways to implement each of these types. Today, we've just walked through one that you can accomplish with Presto and Treasure Data. But I hope this gives you an overview of how you can use workflows to build out data pipelines and how window functions can make those pipelines more succinct. So thank you for sticking around and listening. I'll stop here to see if anyone has any questions.
Cool. Yes, we have a couple coming in, and thank you very much, Scott. Very informative. Deep dive, love it. Okay, so yeah, we have a couple questions coming in. Keep them coming, you guys. So, number 1, are SCDs just for CRM data?
Great question. Yeah, so SCDs, are for more than just CRM. CRM is a great example of SCD data because there's lots of dimensions being recorded for each customer that are prone to change in an unpredictable way. Things like address, phone number, email address, that sort of thing. But any data set can have slowly changing dimensions. I'm thinking of web logs, cookies and IP addresses can change unpredictably for a user. Even transaction data or social data can have these fields that we expect to remain mostly constant, but will change somewhat from time to time.
Okay, great. Got another question here. What about fast changing dimensions? Can these be handled the same way?
Awesome. Yeah. So Fast-changing dimensions are a little different. So just to kind of define what a fast-changing dimension is compared to a slowly changing dimension, fast-changing dimensions are things that will change, but predictably. They're going to change, every time we get, some new data coming in. They're fields like age or, current date time, and when I say age, like age of record. So, every time we receive a new record for a particular ID, this field will change, by definition, because, current date time, is always changing. So, these kind of have to be watched because, as we ingest new data, these will, kind of change artificially and, produce duplicate data or at least, extraneous rows in your data set that you're trying to track changes in. So a couple different ways to handle fast changing dimensions. You'll probably want to exclude these from your SCD data set, or at least include a deduplication step so you don't handle fast changing dimensions in the same way as slowly changing dimensions.
Okay, cool. Great. We've got one more here, and then I think we'll let everybody go back to their lives. So let's see. The solution you showed involves dropping and reloading all of the data in the target table, not just the records that are being updated. What if I want to persist my data in the target table?
Awesome. Cool. Yeah, this is a great question, and I actually made up another slide or two related to this because this question is absolutely right. In the workflow that we walked through, we're dropping and reloading a target table, and in a situation where we had billions of rows in our target table and only a few records that were changing from time to time, that solution wouldn't be as efficient as if we were able to persist the target table. So let's take a look at some of these extra slides here. Let's see. There we go. So yeah, here we go. So yeah, looking at an SCD type 2 workflow that uses a persistent target table, the first step that we want to do is store a temp table of the current rows that will not be current after the new data is ingested. And then we want to delete from the target data table any current rows that have a matching ID in the new data. Insert the temporary rows into the target table, and then insert the new data into the target table. And that would be kind of the simple way to manage SCD type 2s with a persistent architecture.
Great. Oh, and it looks like we got one more question just under the wire, which is great. So we have a requirement for a data connector that wants to do this using the plugin itself. But it looks like these detailed features, repeated rows and staging table, can only be used using a workflow. What I mean is, can we include these features into the plugin itself or suggest using workflow? Is it even advisable to reinvent a plugin to include these features within itself?
This is an interesting question, and definitely feel free to reach out to me so we can dig into this particular use case in even more detail. But at a high level, just in general, I would say that because the customization features of Treasure Data Workflow are so powerful, and that needs and requirements around a particular data connector may change over time. Treasure Data Workflow is a great way to kind of be able to customize the needs of a data pipeline as needs around a connector change. So I would probably lean more towards managing that in Treasure Data Workflow. I hope that addresses your question. If not, feel free to reach out to me, and we can dive into this particular use case in more detail.
Great. Fantastic. Oh, and then we'll reach out. Fabulous. Great. Awesome. So thank you very much, everybody, for joining us. Again, please reach out to Scott or info@treasuredata.com if you have any other questions. Please keep an eye out for more of these hands-on webinars coming in the future. We're trying to do 2 a month. And also let us know if there's some aspect of the product that you would like deep dive or a hands-on workshop like this about. We will do our best to get that scheduled. So thank you, Scott, for joining us. Thanks for all the great information. And we hope everybody has a great day. Thanks.